Hello everyone, I am Albert Enyedy, and in this paper we talk about stereo image-based visual servoing towards feature-based grasping. Our contribution is a stereo vision-based control scheme without using stereo reconstruction. Without any depth sensing or prior knowledge of the object model, we can leverage high-resolution, less noisy 2D image data with a single image feature point to control robot manipulators with high accuracy. As you can see in the bottom image, depth data, you can't even see the ball on the table, whereas in the RGB image, you can. You can see here, we place the racquetball at 3 different depths away from the camera, and after clicking on the ball, in each of the left and right camera images, the controller can now drive the end effector towards the ball and then complete a grasp. As you can see, the end effector is converging to targets at various depths from the camera, using only 2D image features as feedback to complete a grasp. As shown in our graphs, we reach within 1% of the starting error, sufficient for completing our grasp. We can also specify reference orientations as shown still by clicking, which provide our control scheme with grasping and placing target orientations, as shown by the magenta and green lines in the video. The magenta line representing the current orientation observed of the end effector, and the green line representing the desired end effector orientation. As you can see, we can converge in the target point as well as the orientation. As seen in this graph for the pick and place trial, both the position and approach angle error reach within 1% of the starting error, enough to complete the grasp. As seen here, we begin our experiment by having Atlas walk to the target. The bottom 2 videos show the left and right images from the cameras, respectively. They are grayscale. Then we move the arm to the starting configuration and select the fingers and the ball in both the left and right images for our tracking. Then we run our control scheme and minimize the error vector in the image to reach the ball in 3D space without any prior knowledge of its position and complete a grasp. Even from an uncertain starting pose, our controller brings the Atlas arm within 4% of its starting error to complete a grasp.